Hello and welcome back to Machine Learning. I'm Javita Christie, and in this video, we are going to continue with different types of machine learning. Specifically, we are going to study unsupervised learning and reinforcement learning. And if you want to see supervised learning, it's there in the previous video, which I have linked down below. We are also going to compare supervised, unsupervised, and reinforcement learning. So let's begin. Unsupervised learning. Unlike supervised learning, in unsupervised learning, there is no labeled training data to learn from and no prediction to be made. Okay, the two things. One is there is no labeled data, which means you would not be providing it with images of objects that are round, objects that are triangular, and give also the tag, also tagged. Okay, you're not going to provide that. And there's also no prediction to be made. In supervised learning, the objective is to take a data set as input and try to find natural groupings or patterns within the data elements of records. So the idea is to group the data or find interesting patterns in the data. Therefore, unsupervised learning is often called a descriptive model, and the process of unsupervised learning is referred to as pattern discovery or knowledge discovery. One critical application of unsupervised learning is customer segmentation. This is used quite often in business analysis and marketing, where you want to segment your customers based on their interests and then provide them with products and advertisements that cater to their particular interests. Clustering is one of the main types of unsupervised learnings, and it intends to group or organize similar objects together. So just like the name suggests, clustering, we try to form clusters of similar objects. So try to group similar objects together. And for that reason, objects belonging to the same cluster are quite similar to each other, while objects belonging to different clusters are quite dissimilar. So it's in the end, it's all about finding out which object belongs to which cluster. And when you group things together, those groups have lots of, the objects within the groups have lots of similarities. But if you compare one object of one group with object of another group or cluster, there's going to be a lot of differences. And hence the objective of clustering is to discover the intrinsic grouping of unlabeled data and form clusters, as depicted in the following figure, which I'm going to show you now. So this is how clustering looks like if you visualize it. You have some data points, you will group them together on your graph, and this is how clusters can be formed. So sometimes clustering is just very easy based on location on the graph. You just see on the graph where the points are. And if you notice that there are gaps in between, like you can see here, there are gaps, then you can clearly create 4 clusters out of this. Different measures of similarity can be applied for clustering. One of the most commonly adopted similarity measure is distance, like I said. So measures of similarity can be anything. One commonly used measure of similarity is the location on the graph or the distance between two data points. So in the previous diagram, we saw some of the points are very close to each other, so they form a cluster. And whenever there are gaps in between some points and some other points, if there are gaps, you can form 2 clusters. So 2 data items are considered as a part of the same cluster if the distance between them is less. And if the distance between them is more, then they do not belong to the same cluster generally. This is also known as distance-based clustering. Now there's another diagram that's going to depict the process of clustering at a high level. So this is more like process of unsupervised learning. Okay, there is unlabeled data right here, and there's some unsupervised learning happening, and then these items are clustered. Now, it may not always be based on location or based on distance. It could be also based on characteristics of those data items. Other than clustering of data and getting a summarized view from it, one more variant of unsupervised learning is association analysis. Okay, what is association analysis? So as part of this, there is an association found between data elements. Okay, whatever elements you're given, you try to associate them with each other. Let's try to understand this in context of one of the most common examples that, no matter what you're studying, you will be seeing this, which is called market basket analysis. Okay, it's shown here in the diagram. So this diagram shows you what kind of items people are buying. Okay, so this is transaction ID, and these are the items bought. So the transaction ID 1, which means there is one person who bought butter and bread. There's a second person who brought diaper, bread, milk, and beer. The third person brought milk, chicken, beer, diaper, and so on. Okay. Now, what happens with market basket analysis? What happens in that? So first of all, you will find the frequent item sets. What are the two things that are bought together? Okay, mostly bought together. So you'll see that in this list, okay, diaper and beer, they are appearing quite a lot of times together. Like it's happening here in the second transaction, third transaction, fourth one, and fifth one. So it seems that that is the most common pair appearing in all these things. So you can say that these two are frequent item sets. Okay. And there is a possible association that if somebody buys this particular item, they are also going to buy beer. So if somebody's buying diapers, they are also going to buy beer. So from past transaction data in a grocery store, it may be observed that most of the customers who have bought an item A have also bought item B and item C, or at least one of them. This means that there is a strong association of the event purchase of item A with the event purchase of item B or purchase of item C, which means there is some correlation between buying item A and buying item B or C. So identifying these sorts of associations is the goal of association analysis, okay, and it helps in boosting up sales pipeline, hence a critical input for the sales group. So how does it boost up your sales? Because one, you can know that if the milk is selling very fast, then even the bread is going to be in demand, or butter is going to be in demand. So based on the associations that you found from the way people are buying things. Also, if you owned a mall or a mart or something, you could put these items together on the rack, right? If you had some place where you were storing milk in the mart, then maybe right next to it you might want to store bread, because people are most likely to buy bread after buying milk. And if your intention was to buy milk, but then next to it you saw bread, then you would be more likely to buy bread as well, right? So that's unsupervised learning for you. Now we are going to see reinforcement learning. So we have seen babies learn to walk without any prior knowledge of how to do it. Often we wonder how they really do it, and they do it in a relatively simple way. First, they notice somebody else is walking around. For example, parents or anybody else that's living around. They understand that legs have to be used one at a time to take a step. Okay. And while walking, sometimes they are going to fall, hit an obstacle. Okay. Sometimes they'll be able to walk smoothly, avoiding all these obstacles. When they are able to walk, overcoming the obstacles, then their parents are elated and they appreciate them with lots or maybe chocolates, right? That's normally what happens. That's how parents are. It's not just about babies, but even about dogs, right? When you have a new dog and you're trying to teach some trick to the dog, then whenever the dog performs that trick, you give a treat to the dog, and the dog understands that, yes, this is something I'm supposed to do. The same way, the baby understands that when it is walking properly, that is something it has done right, because the parents are clapping or giving chocolates. So when they fall down while circumventing an obstacle, then obviously their parents do not give claps or chocolates. That's just hypothetical, okay? So in that case, A time comes when the babies learn from those mistakes and they are able to walk with much ease because they didn't really need help to learn to walk, but they needed help to learn to know whether they are doing it right. Okay, so the idea is that when they're doing it right, they are rewarded. When they're doing it wrong, they are not rewarded, which makes them understand that this is the right thing to do and this is not the right thing to do. So in the same way, machines often learn to do tasks autonomously. So let's try to understand this in the context of the example of a child learning to walk. Okay, the action tried to be achieved is walking. The child here is the agent, and the place with hurdles and obstacles where the child is trying to walk, it resembles the environment in which the machine is learning. Okay, so there are three things. The task or action is to walk. The agent is the child, and the environment can be, you can draw an analogy between the place where the child is walking with the environment in which the machine is working. So it tries to improve its performance of doing the task. Okay. When a subtask is accomplished successfully, then a reward is given. When it is not executed correctly, then no reward is given. So that's what happens in reinforcement learning. And this will continue till the machine is able to complete execution of the whole task. Okay, so one task is going to be divided into several tasks, and as soon as a subtask is fully done, then a reward is given. As long as it's not done correctly, no reward is given. And so this process continues till the machine has finally finished the whole task. This is known as reinforcement learning. Here we have an example. This is your input raw data. This is the environment in which the machine is learning. So the agent here is the machine, okay? And it is going to select its own algorithm. It's going to select its own best action. It's going to decide which is the best action. And there is this state of the machine and the reward given, okay? So this is how reinforcement learning takes place. And the machine is going to be able to classify these objects, as you can see, into different categories by learning on its own. So there is no labeled data set provided, nothing is given. The machine tries to do everything on its own. That is reinforcement learning. One contemporary example of reinforcement learning is self-driving cars, right? Because the critical information which it needs to take care of our speed limit in different road segments, traffic conditions, road conditions, weather conditions, all these things, okay? And the tasks that it has to do are, it has to start and stop, accelerate and decelerate, which means speed up or slow down. Okay, it has to turn to the left or right, all these tasks it has to perform. And that is why it is reinforcement learning. You cannot essentially train it on some past data. So now we have finished a brief introduction to supervised, unsupervised, and reinforcement learning. So let's take a look at the differences between these, how you can classify them. Okay. So firstly, in supervised learning, it is used when you want to classify given data. Okay. Or in other words, classes or labels are available. When you know how to classify given data, when some labels are already given to you, like we saw in the previous video of supervised learning, right? That the machine is already provided with images of objects that are round and triangular, along with the tags. And in unsupervised learning, there is no idea about the class or label of the data, but the model has to find that pattern in the data. In reinforcement learning, there is no idea about the class or label, okay? The model has to do the classification and it will get rewarded if the classification is correct, else it gets punished. In supervised learning, labeled training data is required and then the model is built on the basis of that training data. In unsupervised learning, any unknown and unlabeled data set can be given to the model and it is going to find groups in that. In reinforcement learning, machine learns on its own through reward and punishment. In supervised learning, the model performance can be evaluated on the basis of how many misclassifications have been done based on a comparison between predicted and actual values. Whereas in unsupervised learning, it's quite difficult to measure if the machine actually found something useful or interesting, because the whole idea is to find some interesting patterns. Okay, so homogeneity, homogeneity of records grouped together is the only measure. So that means the similarities between the objects that are found to be of interesting patterns, of objects that are found to be grouped together, that is our only measure. In reinforcement learning, model is evaluated by means of the reward function, okay, after it had some time to learn. In supervised learning, we have two types, classification and regression. In unsupervised learning, we have clustering and association. In reinforcement, we do not have any such types. The simplest type of learning to understand or implement is supervised learning. Unsupervised is more difficult than supervised, okay, but it's less difficult than reinforcement. And reinforcement is the most complex to understand and apply. And here are some standard algorithms which are used here. So in supervised, we use naive Bayes, KNN, decision tree, linear regression, logistic regression, support vector machine, etc. And for unsupervised, we use K-means algorithm, principal component analysis, self-organizing map, a priori algorithm, and DB-scan, and others. In reinforcement learning, the standard algorithms are Q-learning and SARSA. Okay, let's take a look at some of the applications here. So we have handwriting recognition for supervised learning, stock market prediction, disease prediction, fraud detection, etc. Okay, in unsupervised learning, we can have market basket analysis, which we saw earlier, recommender systems, customer segmentation. I explained that before. In reinforcement learning, you can have all these applications, self-driving cars, intelligent robots, AlphaGo Zero, which is the latest version of DeepMind's AI system playing Go. Okay, Go is a game, so this is a type of model that can play that game. So this is where I'll end this video. In the next video, we are going to see some tools and applications of machine learning. So I'll see you there, and thank you for watching.